In section 4.2, we'll be focusing on the case of a missing diagram. So you'll be reading a statement here, coming up with a diagram, a given, and proof statement. So you're kind of working backwards in a sense. So the first thing that you want to do is make sure that you draw a diagram and label it however you'd like. And then you want to state the given information and what you want to prove. Now, the given and prove must be specific to your diagram. For these problems, you do not actually have to write a proof. Sometimes you may come across some where you will have to write a proof as well, so make sure you read the directions carefully. For the first example, we can find our given and proof statements by reading it. So it says the altitude to the base of an isosceles triangle bisects the vertex angle. So we're given an isosceles triangle, and we have an altitude being drawn to the base. And we want to prove that that altitude bisects the vertex angle. So I'm drawing a triangle first since that's the shape we're working with. I labeled it ABC. You could choose whatever letters you'd like. So I labeled it ABC. And now let's go ahead and write down our given information. So we know we have triangle ABC, and we know that it's an isosceles triangle. But anytime we're mentioning an isosceles triangle, we have to state what the base of that triangle is. So I'm going to say with base BC. It's very important that you state what the base is when you're mentioning an isosceles triangle. So check that off the list. We wrote that in our givens. Next, we have to draw in our altitude to the base. So I'll draw in AD here as our altitude. And you do not have to put in any tick marks on the diagram. Okay, so we're saying that AD is an altitude, and we want to prove that that altitude bisects the vertex angle. Well, the vertex angle is angle BAC at the top. So what's bisecting it? We want to prove that the altitude AD bisects angle BAC, which is our vertex angle. And then we are done. Moving on to example 2. For this one, it says the median to the base of an isosceles triangle divides the triangle into two congruent triangles. Let's find our given information and what we want to prove. So we're given that we have an isosceles triangle again. We have a median being drawn to the base, and we want to prove that that median divides the large triangle into two smaller congruent triangles. So right away, I'd be thinking we have another triangle. Please excuse my drawing here. You know, I'm not working with some straight segments there, but I'm doing my best. So we know that this triangle is isosceles. So once again, we have to state that the triangle is isosceles, and we have to specify the base. And then we have a median that's being drawn to the base. I'm going to call that DG. So we want to state that DG is a median. And what we want to prove in the end is that that median divides the triangle into two congruent triangles. So in the end, we want to prove that we have two congruent triangles. Well, the two smaller congruent triangles that we see here are those two triangles DEG and DFG. So in the end, we want to prove that those two triangles DEG and DFG are congruent to each other. And we are done with example 2. Moving on to example 3, it says, if two altitudes of a triangle are congruent, then the triangle is isosceles. This is kind of nice because it's written as an if-then statement. So it's clear to see that what comes after our if is our given information, and what comes after our then is what we want to prove. Once again, we have a triangle that we're working with, so I'm drawing a triangle. And I'm going to label this triangle this time GHI. Once again, you could choose whichever letters you'd like. And now we have two altitudes that are in the triangle. Okay, so we've drawn the triangle. Now we have to draw in two altitudes. I'm going to start at vertex H and draw in that altitude. And then I'll label that point J. Okay, so HJ is an altitude. And then I'll draw one from vertex I. So IK is an altitude. So we have two altitudes, so we have to mention in our givens that they're altitudes, because whoever is going to prove this proof has to know that those two segments are altitudes. So we know segment HJ and segment IK are altitudes. But if we look in our given information, we have to say that the altitudes are congruent, because it's saying if two altitudes are congruent. Well, we have our two altitudes and they're congruent. So we know that segment HJ is congruent to segment IK. Then we want to prove that the triangle is isosceles. Well, that's our larger triangle. So we want to prove that triangle GHI is isosceles. And then we're done with setting that one up. We'll start back up with the second part of the notes in just a moment.